Ever wondered how those tiny white crystals in your sugar bowl actually come to life? It might seem simple, but behind every spoonful of sugar lies a massive, carefully engineered journey that transforms raw plants into pure sweetness. The process is surprisingly intricate, combining farming, chemistry, and heavy machinery into one seamless operation. Let's take a full, engaging tour through the factory process of how sugar is made, step by step. The story of sugar begins far away from factories, out in the fields where sugar crops are grown. The two main sources of sugar are sugarcane and sugar beet. Sugarcane thrives in tropical and subtropical climates, growing tall like bamboo, while sugar beet is cultivated in cooler regions and grows underground like a root vegetable. Both contain sucrose, the natural sugar that we extract and refine. Farmers carefully prepare the soil, plant the crops, and monitor their growth over several months. Proper irrigation, sunlight, and pest control are essential to ensure a high sugar yield. When the crops reach maturity, harvesting begins. Sugar cane is usually cut close to the ground, either manually with machetes or using mechanical harvesters. The leaves are stripped and the stalks are collected. Sugar beets, on the other hand, are pulled from the soil using specialized machinery that removes the tops and shakes off excess dirt. Timing is critical during harvesting because the sugar content in the plants can decrease if they are left too long after maturity. After harvesting, the crops are quickly transported to the sugar factory. This step must be done efficiently because freshness directly affects the amount of sugar that can be extracted. Trucks loaded with cane or beets arrive at the factory and are weighed and inspected. Samples are often taken to determine sugar content and quality before processing begins. The first stage inside the factory is preparation. For sugarcane, the stalks are washed to remove dirt, dust, and any foreign materials. They are then chopped into smaller pieces using rotating knives. These pieces pass through shredders that break the fibers apart, making it easier to extract juice. In the case of sugar beets, the roots are thoroughly cleaned and sliced into thin strips known as cassettes. These thin slices increase the surface area, allowing for more efficient sugar extraction. Next comes the extraction process, where the goal is to separate the sugar-rich juice from the plant material. For sugarcane, the shredded fibers pass through a series of heavy rollers that crush and press out the juice. Water is often added during this stage to help wash out as much sugar as possible, a method called imbibition. The leftover fibrous material, known as bagasse, is not discarded. It is commonly used as fuel in the factory's boilers, helping to generate energy and making the process more sustainable. For sugar beets, extraction is done using a diffusion process. The cassettes are placed in a large diffuser where hot water flows through them. This allows the sugar to dissolve into the water, creating a raw juice. The remaining beet pulp is separated and typically dried for use as animal feed. At this point, both sugarcane and sugar beet processing have produced a raw juice that contains sugar along with many impurities. The next step is clarification, which is crucial for cleaning the juice. The raw juice contains dirt, plant fibers, proteins, and other unwanted substances. To remove these, the juice is treated with lime, which helps neutralize acids and causes impurities to coagulate. Carbon dioxide is then bubbled through the mixture, forming tiny particles that trap the impurities. This creates a substance that can be filtered out easily. After filtration, the juice becomes much clearer and more suitable for further processing. Even after clarification, the juice still contains a large amount of water. To concentrate the sugar, the juice goes through the evaporation stage. It is heated in large evaporators, often under reduced pressure, which allows water to boil off at lower temperatures. This helps preserve the quality of the sugar. As water evaporates, the juice becomes thicker and transforms into a concentrated syrup. The next stage is crystallization, where the sugar actually begins to form solid crystals. The thick syrup is transferred into vacuum pans, where it is boiled under controlled conditions. Small seed crystals are added to the syrup to encourage the formation of larger crystals. As more water evaporates, sugar molecules start attaching themselves to these seeds, gradually forming visible crystals. This mixture of crystals and syrup is known as masacuate. Once crystallization is complete, the masacuate is sent to centrifuges. These machines spin at very high speeds, separating the sugar crystals from the remaining liquid. The heavier crystals are pushed outward, while the liquid, called molasses, is drained away. Molasses is not wasted. It has many uses, including in food products, fermentation, and even industrial applications. At this stage, the sugar crystals are still slightly wet and may have a light brown color due to traces of molasses. To improve their quality, they go through drying and cooling. Hot air is blown through the sugar to remove moisture, and then it is cooled to stabilize the crystals. The sugar is also screened to ensure uniform size, which is important for packaging and consumer use. For producing white sugar, an additional refining process is often carried out. The raw sugar may be dissolved again, filtered, and recrystallized to remove any remaining color and impurities. This results in the bright white, pure sugar that is commonly used in households. Brown sugar, on the other hand, is produced by either leaving some molasses in the sugar or adding it back after refining, giving it a richer flavor and darker color. Quality control is an important part of the entire process. Samples are taken at different stages to check purity, color, crystal size, and moisture content. Advanced instruments and laboratory tests ensure that the final product meets strict standards. Any deviation can affect taste, texture, or shelf life, so precision is key. Modern sugar factories rely heavily on automation and technology. Sensors and computer systems monitor temperature, pressure, and chemical levels throughout the process. This ensures consistency and efficiency while reducing human error. Workers still play a vital role, overseeing operations and maintaining equipment, but much of the process is controlled digitally. One of the most interesting aspects of sugar production is its efficiency. Almost every part of the plant is used in some way. Bagasse is burned to produce energy, beet pulp is used as animal feed, and molasses finds its way into various industries. This minimizes waste and makes sugar production more environmentally friendly than many people might expect. The scale of sugar production is also impressive. Large factories can process thousands of tons of raw material every day. Despite this massive scale, the fundamental steps remain the same, whether in a small facility or a large industrial plant. The process is carefully designed to maximize yield while maintaining quality. Transportation and storage also play a role after production. Finished sugar is stored in large silos before being packaged into different forms such as granulated sugar, powdered sugar, or cubes. It is then distributed to markets, food manufacturers, and other industries. Proper storage conditions are essential to prevent moisture absorption and maintain quality. The entire journey from field to table is a remarkable combination of agriculture, engineering, and chemistry. Each stage builds upon the previous one, gradually transforming raw plant material into the pure, sweet crystals we use every day. It is a process that often goes unnoticed, yet it plays a vital role in the global food industry. Understanding how sugar is made also gives a deeper appreciation for the effort and technology involved. What seems like a simple ingredient is actually the result of months of farming and hours of precise industrial processing. Every grain of sugar carries the story of careful cultivation and advanced manufacturing. So the next time you add sugar to your tea or sprinkle it over your favorite dessert, take a moment to think about the incredible journey it has taken. From sunlit fields to powerful machines and careful refinement, sugar production is truly a fascinating process. If you enjoyed this detailed and engaging breakdown, make sure to like, subscribe, and drop a comment about what process you want to explore next.